Good morning, friends. Hypothesis. Test of hypothesis. A test of hypothesis is a procedure which specifies a set of rules for decision, whether to accept or reject the hypothesis under consideration. Null hypothesis. Null hypothesis. A statistical hypothesis which is set up, assumed, and whose validity is tested for possible rejection on the basis of sample observation is called a null hypothesis. It is denoted by H0 and tested against alternatives. Test of hypothesis deals with rejection or acceptance of the null hypothesis only. Professor R. A. Fisher remarked a null hypothesis and his hypothesis which is to be tested for possible rejection under the assumption it is true. Alternative hypothesis. The negation of null hypothesis is called alternative hypothesis. It is denoted by H1 and H infinity. It is not tested, but its acceptance rejection depends on the rejection acceptance of the null hypothesis. Alternative hypothesis contradicts the null hypothesis. Critical region, rejection region, the set of value of the statistical which leads to rejection of the null hypothesis is called critical region of the test. The probability with which is true null hypothesis is rejected by the test is often referred to as size of the critical region. One on the other hand which lead to acceptance of the null hypothesis give us a region called a acceptance region. The critical value separates the rejected region from the acceptance region. Level of significance. The maximum probability with which a true null hypothesis is rejected is known as level of significance of the test. Second, it is denoted by third, in framing decision rules, the level of significance is arbitrarily chosen in advance depending on the consequence of the statistical decision. Generally 5%, 1% level of significance is taken, although other levels such as 2% and 1.2% are also used. Degree of freedom. It is the value of a sample which are freely variable without affecting the mean, or it is an integer used to determine whether a chi-square value is statistically significant. The number of data are given in form of series of variable in a row of column, or the number of frequency that you are put in the cells in a contingency table which can be calculated independently is called degree of freedom and is denoted by df. Calculation of degree of freedom. If data is given in the form of a series of variables in a rows of columns, then the degree of freedom df is equal to number of items in the series minus 1. df is equal to n minus 1, where n is the number of observation. When the number of frequencies are put in cells in a contingency table, degree of freedom will be product of number of rows less 1 and number of column less 1. If degree of freedom r minus 1 into c minus 1, where r is the number of the rows and c number of the columns. Conditions for using the chi-square test. Each observation making up sample for the set test should be independent of each other. Chi-square test applied in a four-fold table and will not give a reliable results with 1 degree of freedom if then expected value in any cell is less than 5. In such cases, to apply chi-square test, Yates correlation is necessary. The total number of observations used in this test must be large. I number is equal to 50. The test is used only for drawing inference by testing hypothesis is ordered for the estimation of parameters or any other values. It is wholly dependent on degree of freedom. The frequency used in multiplied by 2 tests should be absolute and no relative in terms. The observation collected for multiplied by 2 tests should be non-random basis of sampling and types chi-square, goodness of fit, contingency chi-square, homogeneity chi-square, test of goodness of fit and Pearson chi-square. Chi-square test is also applied to a test of goodness of fit. Determine whether the actual observed number of frequency are similar in good agreement with the expected theoretical number of frequency. Thus, the test is called goodness of fit. Null hypothesis assumes the goodness of fit. First, 1:1 monomery test cross ratio. 3:1 simple mono-hybrid Mendelian ratio F2. 9:2, 3:3:1 simple Mendelian dihybrid ratio. 1:1:1:1 dihybrid test cross ratio. Two types of error. The decision of acceptance or rejection of the null hypothesis is made on the basis of the sample from a population, and hence the element of uncertainty is always involved in making such decision. Two types of errors are likely to be committed in the procedure of testing a hypothesis. These are type 1 and type 2 error. Type 1 error is committed when true null hypothesis is rejected. The probability of this error is termed as level of the significance of the test, will be denoted by alpha. The probability of committing an error is also termed as size. Contrary to type 2 error committed when a false null hypothesis is accepted, and the probability of type 2 error is denoted by beta. This is the acceptance hypothesis. 0.95 accept the null hypothesis if a sample falls in this region mu r.1. 0.025 rejection region. 0.025 rejection the null hypothesis if the sample fails in these two regions. Two-tailed or one-tailed test of hypothesis. 0.95 acceptance hypothesis. Rejection of the tool test of hypothesis will reject the null hypothesis if the sample statistics is significant, higher than the lower than the hypothesized population parameter. Thus, two-tailed test, the rejection is located first both the tails. A two-tailed test is appropriate when the null hypothesis is mu is equal to mu h being some specified values, and the alternative hypothesis mu is equal to mu h naught, while one-tailed test is so called because the rejection level will be located in only one tail, which may be either left or right depending upon the alternative hypothesis formulated. To test the hypothesis that the population has a specified mean mu 0, then null hypothesis h naught is equal to mu 0, mu naught. Alternative hypothesis h1 mu is equal to naught mu 0, mu naught. Two-tailed alternative hypothesis h is to mu is greater than mu 0. Right-tailed alternative hypothesis h is to mu is less than mu naught. Left alternative hypothesis. Thank you.